Hi guys, welcome. Today we're going to create a to-do app using Flat. We can add to-dos, modify and delete them. To-do app covers basics of Flat very well. Flat is based on Flutter and brings Flutter's availability and flexibility to Python. Let me show you how. First install Flat and import it as FT. Let's create our main function and pass page as an attribute. Page is the root window. Change the height to 600 pixels and its width to 400 using page.window height and width. To apply the changes, we should call the update method of page. Finally, we call ft.app and pass main function to its target attribute. These are basics of Flat. If you're not familiar with it, please first watch the Flat introduction video to understand its features and how it works. Run the app using Flat instead of Python to utilize the great hot reload feature of Flat. Now you can change the title, and as soon as I press save, changes are applied and we don't need to rerun the app. To keep the code clean and create reusable components, we create custom widgets by creating classes. That's way better than nesting functions in main function. Go ahead and create to-do class and pass ft.userControl to it. Let's create build method which returns a text control. To create custom controls or widgets, we need to create a class which inherits the userControl class. All the controls or widgets derive from userControl. This build method comes from userControl. We override it and return a single control or multiple widgets using containers like rows and columns. Whatever is returned in the build method is our custom widget. That's simple. If you're not comfortable with classes and object-oriented programming concept, I strongly recommend watching the class and OOP video before this one to fully understand what happens. Let's test our custom widget. Create an instance of to-do class and add it to the page. When we use add method, we don't need to update the page as add method does it for us. Great, we created a custom control. Now let's create the first part of our app. First, we create a text field to get the user input and store it in self.input. Expand lets the text field occupy all the available space. Then we create self.tasks, which has an empty column, a container for the tasks that we add later. These two are class fields or attributes because we need to modify them in other methods of the class later. Create view variable. It's a column which first contains a text widget with the value of to-dos. We can style it by passing ft.textThemeStyle to its style attribute. The error is because of that we haven't returned anything in the build method yet. Let's set the horizontal alignment to ft.crossAxisAlignments.center and return view. Now error is gone. Next we create a row. We can nest columns and rows as much as we want. We put self.input, which is our text field, and add a floating action button. This button is for adding tasks. I set its icon property to add icon. You can access tons of modern icons for free using ft.icons. Finally, pass self.addClick to its onClick attribute. So when the button is clicked, the function will be executed. Let's create the function and pass e to it. E is the event handler and should be there, but we don't need to use it necessarily. Pass the function for now. Let's test it. That's nice. I want to tap in the text field and press the button to create a task or to-do. For that, let's create a separate class named task. Task also should derive from userControl and return a control or widget in its build method. For now, a task that says a task. Let's create an instance of task class in addClick method of to-do class and append it to the controls of self.tasks. Controls attribute of column and rows are lists, so we can easily append items into them. Finally, we call self.update. When we want to update a custom widget, we call self.update. Let's add self.task to the view. As you see, when the button is pressed, task controls get added vertically because self.tasks is a column. Now that it works fine, let's create a task control. We need to get user's input first, so create a constructor and pass input text to it. Whenever you call the constructor of a custom control, you must call the superclass's constructor too. Then store input text in self.input. Now that we have the user's input, we can create a checkbox and set its label to self.input and expand it to occupy all the available space and store it in self.taskcb. Next we create a text field and pass self.input to it. This text field is used to edit and modify the task later. Then we create self.task view, which is a row to contain the checkbox that we have already created and two icon buttons, one to edit and one to delete the task. Let's create the functions and pass them for now. Next is edit view, which is also a row containing the text field that we created and an icon button to save the modified text. At the same time, you have two widgets, task view, which is the task, and edit view, which is for editing the task. All the widgets or controls have visible attribute which is true by default. If you make it false, user cannot see it. So the edit view's visibility is false and task view's visibility is true, which means edit view is hidden by default. Let's first assign the functions to the buttons. I'll return both of them in a column to see how they look. And don't forget that task class needs the user's input to be initialized. As you see, when the task is added, we only see the task view because its visibility is true and edit view's visibility is false. Now let's implement methods. First one is edit clicked. Simply we make task view's visibility false and edit view's true, and update the control. When we click the save button, we reverse their visibility and change the task CB labels text to the value of edit text field. It's working fine, but when we add a task, the text field should reset and delete the text that we've entered previously. For that, we need to go to add_collective to the class and empty the text field out after adding each task. To delete each task, we need to create a method in to-do class, which will be passed to task class and delete the task. As you see, we pass a task and simply tap into controls of self.tasks column and remove the task which is given and call self.update. Now we can create a variable to get that function in the constructor of task class. And simply we use it and pass self, which means that specific instance of the class to get removed. And we don't need to call self.update as we did in the remove task method of to-do class. And finally, we should provide the remove task while instantiating the task class. Let's mitigate these empty tasks before testing the delete functionality. We simply check if the self.input text field is not empty, and then we create a task. Otherwise, we don't. Let's see how our app works. We can add tasks, modify them, and finally delete them. Congratulations! You created a nice looking to-do app in Flat and Python. Please like the video if you enjoyed it and subscribe to the channel for more cool stuff. Take care, see you later. Today we'll build our own text editor in Flat and Python. Flat is based on Flutter for Python and gives the opportunity to build such a beautiful app. We will use snack bar, alert dialog, shortcut keys and much more in this app. Let's get started. Let's first install Flat via pip. Import Flat as FT and create main function. We pass page to the function, which is a type of ft.page. Page is our root window. Now you can change the height and width of the window, and call page.update to apply the changes. Finally, we call ft.app outside of the function and pass main function to its target attribute run the app. I run the app with Flat instead of Python in terminal, so you can use hot reload feature of Flat. So when we make a change in our app, it automatically gets applied in the real time and we don't need to close and run the app again. These are the basics. If you're not familiar with Flat, you can first watch the Flat introduction video. Let's create a class named TextEditor which derives from ft.userControl, and we need to return a control or widget in its build method like a text control. Now you can create an instance of TextEditor class and add it to the page. When we use add method, we don't need to call update, as add method does it for us. As you see, the text is added to the top of the page. When we want to create a custom control or widget, we create a class that derives from userControl and return the widget in the build method. All the widgets or controls are made this way. We can nest functions in main function, but I like to keep the code clean, so we do most of the things in TextEditor class. Let's pass the page to its constructor so we can manipulate the page directly in the TextEditor class. Whenever you call the constructor of a class that derives from userControl, you must call the superclass constructor too. Self.page equals page. So now we can manipulate our root window using self.page. If you're not comfortable with classes and object-oriented programming, I strongly recommend watching the classes and OOP video before this one. Now we need to pass page to the instance that we created so it won't break. Now that everything is set up, let's build our text editor. In the build method, we create a text field and store it in self.main.tf. We want our text field to be multi-lined to have as many lines as we want. Autofocused, so when the application is run, we can start typing right away. Its border is equal to ft.inputBorder.none, so we don't have a border around the text field. Let's return self.main.tf. As you see, we can type right away, have as many lines as we want, and we have no border around it. But the problem is, when we reach the end of the window, it doesn't get scrolled. To fix that, we will set page.scroll to ft.scrollMode.always. So when we reach the end of the page, it gets scrolled. You can have different scroll modes, but this one is the best for a text editor. Next, let's append the container to the overlay of the page. The container has the padding of 5 to have some distances from the edges, expanded so it occupies all the available space, and background color is amber 200. You can change the color to whatever you want. FT Colors has tons of different colors with different tones available. The number after the name is for the tone of the color. Finally, the content of the container is a row. As you see, an amber line is added to the top of the page. That's our overlay that no matter what is at the top of our page, even if you scroll the page. Let's now create pop-up menu button and store it in self.more menu. Its content is an icon which we pass ft.icons.morevert. You can access tons of icons via ft.icons class. Items is a list of pop-up menu items which are different options of our menu. First item, we pass self.newClick to its onClick attribute. We will create the method later. Its content is a row which first has a text widget that says new, then a vertical divider, and finally another text widget that shows the shortcut key for the command to the user. The vertical divider puts in space between two text widgets to be more organized. Note that all the content of the row are in a list. Let's add our more menu to the overlay. It's working fine, but as you see, the text goes under the overlay. Let's quickly return a column which has first a divider, then the self.maintf text field. Opacity of the divider is 0, so it's invisible. Because of the divider, we now have a space between the text field and the overlay. Now let's add 3 more items to the more menu. First one was new, which gives us a new text field to type. Next, open, which is for opening a text file. Next one is save as, to save the file on your hard disk. And finally, save to save the file whenever we change it. The onClick attribute is commented out so the app doesn't return an error as we haven't created them yet. Let's test it. We need to change the alignment so they'll look better. We need to give the name of the list, which is controls, and set the alignment to ft.mainAxis alignment, that's space between. That looks great. Let's do the same for other items. Nice. Now we can create the methods and give functionality to the items of the menu. These methods should have an event handler, which I name it E. Later I show its use case. For now, let it be there. Let's uncomment the onClick attribute and test them. They are linked properly. Now let's link shortcut keys to the methods. To do that, we create onKeyboard method, which its E is a type of ft.keyboard event. So this event handler lets us know what keys are pressed. If Ctrl and N are pressed, then call newClicked method, and we need to pass E to the method. If Ctrl and O are pressed, we call openClicked. If Ctrl and Shift and S are pressed, we call save as. Finally, if Ctrl and S but not Shift are pressed, we call saveClicked method. E.Ctrl and E.Shift are booleans and E.key is a string, so we know exactly what buttons are pressed on the keyboard. Finally, we should set self.page.onKeyboard event, which is a flat function to return pressed keys to self.onKeyboard that we created. Self.page.onKeyboard event automatically returns the key through the E variable that we specified for the onKeyboard method. That's why we need a variable for all state manager methods that we create. They are all there to receive some data that possibly can be used, like this case of shortcut keys. When I press Ctrl+N, newClicked is printed. Other shortcuts work as well. Great. Now you can write the functionality of the items. When new is pressed, I want to give the user a fresh text field to type on. So you empty the value of self.maintf and update its state. When I press Ctrl+N, the text field gets emptied out. In open method, we want to open a native file picker so the user can choose a file to work on it in our text editor. So we need to use ft.filePicker and set its onResult attribute to another function, so when we choose a file, that function gets executed. The event handler in this case is an instance of FilePicker result event. Then the FilePicker should be added to the page. I append it to the overlay. FilePicker doesn't change our layout, so you can add it to the main page itself. It has a size of 0 on the page and opens another one for us. Finally, we want to use pickFiles method of the FilePicker. We don't want the user to pick multiple files. Then we can set allowed extensions. It's a list. And finally, set the title to open file. All of these were to open the file picker. When we choose a file, FilePicker sends data of the file that we picked through the event handler, which is the E attribute of open file result. Then it gets executed. So let's print E.files out to see what data we get from the file picker. So E.files is a list that contains FilePicker file object. So we can now have the path and name of the file easily. First, let's get the path. We want the first index of the list and then the path. That's simple. Then we can get the name of the file the same way and store it in self.filename. So we can change the title of the app to the name of the file and a title suffix that we will create soon. I want the title suffix be the name of the app, which is Pilot, Python Unflat. And when we run the app, we have new file as the name of the file by default. Back to the open result method. Now that we have the file path, we can store it in a class field to access it later across the class. Then open the file in the read mode as file, and we set the value of our text field as the file.read, which is the content of the file that we've selected. Finally, we update the self.maintf and the page so the title gets updated. Now when we pick a file, we get its value and change the title to its name so we know what file we are working on. But I want to notify the user that a new file was opened. For that, let's create another method named custom_snackbar. Our function gets a text and an icon. These are not event handlers. We don't need an event handler because this one just activates a widget for us. Self.page.snackbar equals ft.snackbar with the color of amber 200. Open is true, which says open it up, and its content is a row, alignment is center, or ft.inAxis alignment that's center. They are the same. And it has two controls, the text and icon that we specify when the method is called. Now when we open a file, App beautifully tells us what happened. Let's change the color of the text. For the save as clicked method, we copy the file picker of openFile method and change the unresolved attribute of the file picker to save as result method. Also, the method of the file picker should be save file. Let's print e.path out. Oh, I forgot to remove allow multiple attribute because the save file method doesn't have such an attribute. So e.path gives us the path. This is different to the openFile method, as here we use save file method of file picker, not pick files. Let's first change the title of the file picker to save as, and also set the default name of the file to new file. Let's test it. Okay, now you can save the file to the hard disk. We open the file in the write mode as file. Open function is a built-in function to manipulate files. First argument is the path to the file, and second is its mode, which is a string. It has different modes, but we need write and read mode here. So we open the file and write the value of our text field to it. Then we update the self.current file path for later use. Now we need to change the title to the name of the file that we saved. For that we split e.path and pass double backslash to split. That means separate the content of e.path by backslashes. We use double backslash as backslash itself is escape character, so we need to make it double. This gives us a list that its last item is the name of the file. So you can change the title to file name index -1 plus self.title suffix. -1 gives us the last item of a list, and name of the file is always the last item. Finally, we call the custom snack bar to notify the user and update the page. Let's test it. I save the file and open it to see if the content is saved. Good. It's save method's turn. We first check if the self.current file path is empty. If it's empty, then we simply call self.saveAsClick to go through the process of saving it on the hard disk. Otherwise, we open self.current file path as file in the read mode and check if the value of the text field is the same as the value of the file. If they are different, self.text is different is true. So if the text is different, we again open the file, but this time in write mode as writable file, and write the value of the text field to the writable file and make self.isText different false, as they are the same now. Finally, we notify the user through the snack bar and update the page. If text wasn't different at the first place, we don't need to do anything and pass. Let's test it. Oh, this is self.maintf, not fd.maintf. Let's first create a file, then open it. Save as works perfectly. If I try to save the file, nothing happens, as the text isn't changed at all. But when I change it, the file will be saved. I don't like the icon. Let's change it. Next, I want a pop-up menu button to change the font size and family. Let's go to the build method and create it as self.font menu. Its content is an icon and it contains just one item, which is a column. The first control is a text which says font. Let's add it to the overlay to see how it looks. Now let's create a slider as self.fontSize slider. A text field is better to change the font size, but I want to show you how sliders work in Flat. So the min is 0, max is 200, and divisions are also 200. So you can go from 0 to 200 and it gets increased one by one. Its default value is 14, as the text field in Flat has the default font size of 14. Its label is the value itself, so the user sees the value that they choose. And its unchanged attribute is set to self.fontSizeChanged. Let's create the function. And set the text size of the text field to the value of our slider. And update the text field. Notice that we don't need to update the whole page here, which saves performance and energy. Let's add the slider to the font menu and test it. Now you can create a drop-down to change the font. Its unchanged is equal to self.fontChanged method. Its alignment is center. Its width is 150 pixels. Its label is equal to font family. And finally, its options is a list that we specify shortly. Let's create fontChanged method and add the drop-down to the font menu. In the fonts folder where my script is running from, I have 5 .ttf font files downloaded from Google Fonts. In flat.ttf, .ttc, and .otf format is supported. So you specify the fonts of the page as a dictionary. The key is its custom name that we declare, and the value is the path to the font. I've written them already to save the time. I will tell the flat that our asset directory is fonts folder. I quickly created drop-down options for the font family, and their text is exactly what we had in the fonts dictionary. Now we should change the font family of self.maintf.textstyle to the value of the drop-down that we choose, and update the text field. This won't work unless we specify the font family of the text field. I just set the font family to none. This lets the text field change its font. Perfect. Last thing, I want to show an alert dialog to the user before closing the palette editor if the file is not saved. So it can't be closed that easy, and user doesn't lose its file accidentally. Let's create custom close event method and pass it for now. Then we need to set self.isTextDifferent when we save as the file and open the file to false. If you remember, self.isTextDifferent is used to check if the text needs to be saved or not. Then in the constructor we set self.textIsDifferent to true, as when we have a fresh new file it's not saved. Also self.current file path is empty. Then we set self.pageWindowPreventClose to true, so the window can't be closed. And set self.pageOnWindow event to self.customClose event. This onWindow event gives us different window events like minimizing, resizing, and closing it. Let's test custom close event method. It returns all the events that one of them is closed. So first we create self.custom dialog, which is an alert dialog. Open is true, title is please confirm, and its content says that the file hasn't been saved. Actions is a list of widgets. We need 3 text buttons. First one is save. Second is close anyway. And last one is cancel. If e.data is equal to close, this checks if user has pressed the close button. If self.current file path is empty or text is different, we show the custom dialog and update the page. Otherwise, the file is saved and we just call self.page window destroy to close the app. I almost forgot that when we change the text field's value, we should change self.isText different. Let's pass self.text change to the unchanged attribute of our text field, and change the value of self.text is different to true. Finally, we create the methods of alert dialog buttons. If user pressed the save button, we call self.save clicked and sleep for a small amount of time, then we call the self.page window destroy. I wanted to use threading for this, as we need to wait to save the file first, then destroy the window, but threading is out of the scope of this video. Unfortunately, time.sleep did the job. So let's import time. If user presses close anyway button, we just close the app. And if cancel clicked, we close the dialog box and update the page so user can continue their work. And it works perfectly. When text is changed, we make self.isText field true, not false. It's done. Let's have a final look. Open, save, and save as work perfectly, and shortcut keys make it look professional. Also, the font size and family changing is cool. Congrats to us for creating this beautiful text editor in Flat. Please give me a thumb up, like the video if you enjoyed it, and subscribe to the channel for more cool stuff. Today we'll be building a BMI calculator with a modern GUI using custom tkinter. Let's do it. Import custom tkinter as ctk, then we create the window named root by calling the ctk.ctk. Then set the title to BMI calculator, and then the geometry to 335x235. And finally, let's give it a padding by 20 pixels in each vector using config method. Let's create 2 labels, weight and height, to tell the user what we want. We want weight in kilograms and height in meters, and then we grid them. Then weight and height entries to get the user input. We can give a corner radius to our entries which rounds the entry corners. Now we need a button to submit the user data and show the result. We pass the calculate function that we will build soon to the command attribute, and we specify the column span instead of column, which tells this button occupy 2 columns. Next we create a string var with the value of an empty string, and in the result label we pass the result var to its text variable attribute. We give it font Arial and size of 10, and text color white. Finally, we grid our result label and call the main loop function. Before testing, let's see what's the differences between tkinter and custom tkinter. Well, in custom tkinter, widgets start with ctk and differentiates them from the default tkinter widgets. For example, ctk button and ctk label are called button and label in tkinter. Also, we don't have the corner radius in default entry of tkinter, and we should change them somewhere else. And we don't have text color for labels in tkinter. Now let's test it. This is way better than tkinter, more modern. The labels need some padding, let's add them. Now it's fine, but let me show you a cool default feature of custom tkinter. We can specify the appearance mode to 3 default options: dark, light, and system. We set the light mode, now let's try dark mode. And it looks amazing. Now let's change the color theme to green. Perfect, really more engaging than the default Tkinter. Now let's write our calculate function. First we create two variables to store the user input, weight and height. Then we wrap the user input with the float function to convert it from string to float. Get method of entries give us the user's input. Now we can calculate the BMI, weight divided by height squared. This can give us numbers with 10 decimals, so we need to round it to just 1 decimal using round function. Now we know the user's BMI, let's see their efficiency and show it to them. If the BMI is less than 18.5, we change the color of result label to blue using config method and set the result var. We first tell the user their BMI, then we go to the new line and tell their rank, and again new line and telling them what they need to do. Let's do this 4 more times. If BMI is between 24.9 and 18.5, it's normal, and we change the text color to light green. If it's between 29.9 and 25, BMI is overweight, and we change the color to yellow. If BMI is between 34.9 and 30, it's obese, and the text color is orange. And more than 35, it's extreme obese, and text color is red. This should be greater equal actually. It's done. I've converted this app to Tkinter, and as you see I've commented out these text color changes because Tkinter label doesn't have such attribute. We can change the theme and color to dark. To do that in Tkinter we need to use theme use function, which has no dark or updated theme, and all of them are old. Also the widgets names are normal and have no CTK at the beginning. Also entries don't have corner radius to round the corners. We should write more code to do that. And finally, we don't have text color in Tkinter labels. Let's run both Tkinter and custom Tkinter versions together. These two apps come from two different roles. The color changes were very easy to do. We can do that in Tkinter too, but we need to code more. The custom Tkinter GUI is very beautiful and modern and attracts the user. Dark mode is definitely a huge default factor, and button style and color is great. I hope you've enjoyed creating this beautiful functioning app using custom Tkinter. Please consider liking the video and subscribing to the channel for more. Today we'll be building this nice looking currency converter using Flat, which is powered by Flutter to design UI. You can pick different currencies and convert the amount you want to get the latest prices. Let's get started. Let's first install Flat using pip and also Forex Python to convert currencies. Import Flat as FT from forexpython.converter, import currency rates and currency codes. We create a function named main that has page parameter as a type of ft.page. Page is our root window. Now we can change the height and width of the page and call page.update to apply the changes. To run the app, we call ft.app and pass main function to its target attribute. But instead of Python, we run the script with Flat to utilize its hot reload feature. So if we change something, changes get applied after saving the script, and we don't need to close or run the app every time we manipulate it. For this app, I want 300 pixels of height and 1000 for width. Let's create a class named app which derives from ft.userControl, and we return a control or widget in its build method. That's how we create a custom widget in Flat. It should derive from userControl and return whatever widget we want in the build method. Now in the main method we create an instance of app class and add it to the page. When we use add method we don't need to call update anymore. In build method let's create a text field which its label attribute is equal to amount and store it in self.amountTF. Then a dropdown which its label is equal to from, and its first option is USD space dash space United States dollar. Then we copy it and change the label to 2 and the name to self.2db. The options of a dropdown should be an instance of ft.dropdown.option. So you get the user input with self.amountTF, then user can choose currencies to convert using from and to dropdowns. For now we only have US dollar and we add the rest very soon. Let's create a self.result call, which is a column to show the result, with alignment of center and spacing of 0. Spacing is the space between members of the column that I want it to be 0. Then we return a column, which its alignment and horizontal alignment is center, which means center in all directions. Its controls are first a row which contains self.amountTF, from dp and to dp that we created, and second the result column. Let's see what we've created so far. Well, I want them to be evenly spaced, so let's do it. Nice, that looks good to me. Let's create add currency method to add all the currencies to our dropdowns. But before that, we need to create instances of currency rates and currency codes in the constructor to keep the code cleaner. So we call the constructor, and of course the superclasses constructor should be always called in a custom widget. Then I create self.cr for currency rates and self.cc for currency codes. You can change the names to avoid confusion. Then in add currency method we call self.cr.getRates and pass USD to it. Then we store it in all currencies variable. Let's print it out. But before that, we should call the function in build method so it gets executed when we hot reload the app. As you see, self.cr.getRates gives all the currency prices compared to the currency that we pass to it in a dictionary. I use this to get the currency codes, not prices. I don't care about the rates. For I in list of all currencies.keys. This gives us all the keys of the dictionary, which are all currency codes, and converts it to a list. Print I. Let's see what I is. Great, we now have all the currency codes and can fill the dropdowns out. So we tap into self.fromdp.options, which is a list, and append to it a ft.dropdown.option. It says string, so first we want I, which is the currency code, plus space dash space, plus self.cc.getCurrencyName, and we pass I to it. GetCurrencyName gives the full name of the code that we pass to it. Let's copy this and change the name to self.2dp, so we fill both dropdowns. As you see, we have all the available currencies with their codes and their full names. I want the user to enter a value and select two currencies from the dropdowns, and when a button that we will create very soon is pressed, we convert the value of currency from this dropdown, which is from dropdown, to this one, which is to dropdown. Now all we need is converting the currencies and show the result to the user. For that, let's create convertCollect method and pass e to it, which is an event handler and should be there, but we don't need to use it necessarily. And pass the function for now. Then we go to column that we return in the build method, and before the result column, we put a text button which says convert, and its onClick attribute is set to convertCollect. So when we click the convert button, convertCollect method gets executed. We call self.cr.convert method. Its first attribute is the base currency code, which we get from self.fromdp.value in the brackets :3. This gives us the first three indexes of the string, which always is the currency code. The second attribute is destination currency code, which we get it from to dropdown. And the last attribute is the amount that we want to convert, which is the value of self.amounttf, but we need to convert it to float as it says string. Let's print the result. Let's convert $1 to euro by pressing convert button. As you see, we have a lot of decimal numbers. Let's reduce it to 3. Rounded result is equal to round. First attribute is the result, and second is the number of decimals that you want. I want 3. Let's print it out. It's better. Now we can show the result to the user. We need to call self.cc.getSymbol and pass the currency code, which is the first three indexes of dropdown's values, the same as we did to get the result. Then we get the names from the dropdown values, which are from index 6 to the end of the string. Now we create result text, a text widget, which is a if string. First we put toSymbol, rounded result, space, toName, and set its size to 35, because I want it to catch user's eyes, and its color is black. Then we check if the float of the value that user entered is greater than the result. If so, we change the color of the result to green. That means the destination currency has more value than the base currency. And if they have the same value, the color stays black, and else color is red, which means the destination currency has less value than the base currency. Finally, we clear the result column controls by calling clear method. Then we extend its controls. Controls is a list, so we can append items to it. But if you want to add multiple items, we use extend. So you extend it by a list, which its first item is a ft.text, which is a if string. We want from symbol, the value of amount tf, space, from name, and second item is result text. And finally, we call self.update to apply the changes that we've made. Let's test it. Great, we first have the currency symbol, then the amount followed by the name of the currency. But we need an equal sign at the end of the first sentence. And now it's perfect. The currency symbol actually is the same as the name of the currency, and they don't come together normally. But I wanted to show you how we can get the symbol, and after all, it's our app, and we can do whatever we want. The UI is cool, color changing of the result makes it easier to read, and it looks professional. If you like Flat framework and want to make more apps in Flat, watch these videos. That's it guys, please like the video if you've enjoyed it and subscribe to the channel for more cool stuff. Today we'll be building a keylogger. A keystroke logger is a piece of software or hardware which logs all the keys on the keyboard that are pressed. Some companies use keyloggers for monitoring their employees' works. Also, parents use them to supervise and protect their children. But attackers use a keylogger to steal important information. So bear in mind that this video is just for educational purposes only, and you shall not misuse this information to gain unauthorized access. With this being said, let's get started. Let's first install PyInput. From PyInput, import keyboard. With keyboard.listener as listener, we call listener's join method, which blocks the main thread. Works exactly like a while loop, listening to the keyboard keystrokes. We assign onPress, keyPress, and onRelease, keyrelease functions for the listener. Let's create functions and pass an attribute to them. I name it key. When we press a button, keyPress function gets called and the key that was pressed is passed to it through key attribute that we declared. The same process is repeated when we release a key for the keyrelease function. Now let's first create a list to store the pressed keys. Then in the keyPress function, we try to append the key that was pressed to the keys list, and print the list for testing. If program couldn't append the key, we just pass and do nothing. In the keyrelease function, if the key that was pressed is equal to escape button, return false, which means break the listener and app gets closed. Let's test it. When I press a key, it gets added to the list as expected, and when I press escape, the app gets closed. Now we need to log the keystrokes and save it somewhere. For that, let's call logKeys function and pass the keys list to it. For list of keys, let's print k and its type. As you see, it looks like a string, but it's a PyInput custom class. So you first need to convert it to a string and remove the single quotation marks before saving it to a file on the hard disk. Result equals string of k and replace single quotations with nothing, which deletes them. Replace method looks for the first character that we pass to it and tries to replace it with the second character, which in this case is just an empty string. Let's see what result is now. Nice, we have keystrokes without quotation marks as a string. Now we open a file named log.txt in the append mode as log, and write result plus and space to it. I add a space to improve the readability. You can add dashes or nothing instead. And finally, outside of the for loop, we clear the list of keys, which is actually keys list, to avoid duplication of keystrokes. Let's test it. For example, I want to log into my Gmail account, which is test@gmail.com, and enter my password, which is secretpass12345. And I press escape to exit the app. In real keyloggers, there is no such an exit button, and it's always running in the background. Let's see if log.txt file has been created in the directory that the script is running from. And this is how an attacker steals sensitive information. This was a very primitive and simple keylogger. If you like it, please tell me in the comment section below. And I expand the app towards a real-world keylogger which logs the keystrokes every certain amount of time and even takes screenshots of the infected system and send them to owner of the keylogger. Once again, this video is made for educational purposes only, and author of this video, which is me, is not responsible for any misuse of this information. If you enjoyed the video, please like and subscribe to the channel, and don't forget to tell me in the comment section if you want the part 2 of the keylogger to make it more advanced. Today we'll create an email sender with a good looking graphical interface. For the GUI, we'll use Flat framework, which is based on Flutter that makes it really easy to build modern, nice looking interfaces. Also, we send emails using SMTP module, which is safe and simple. But the tricky part is the password that we use to send the mail for Gmail. For safety reasons, we can't use the password that we use to log into the account itself. Instead, we have to generate an app password, which is a new feature of Gmail to be able to send mails through a third-party app. So first we create the UI and then the functionality of the app. Let's get started. Install Flat via pip. Import Flat as FT and create main function that has page attribute. Page is an instance of ft.page, which is our root window. Let's set the height to 600 pixels and width to 550 and call page.update to apply the changes. Outside of the function, we call ft.app and set its target attribute to main function. Now you can run this script, but instead of Python, we run the app with Flat, which enables hot reload feature of Flat, and if I change the height to 400 and save the script, the changes get applied immediately. and we don't need to close and rerun the app for every single change. Let's create a class named emailSender which derives from ft.userControl and return a widget in its build method like a text widget. Then create an instance of the class and add it to the page. When add is called, we don't need to call update anymore. Save the script, and there it is, hello world. Now you can build the UI. First we declare self.senderTF, which is a text field with the label from and height of 50 for the sender email address. Then self.senderPassTF to get the password with the label equal to password, password attribute equal to true. Also set canRevealPassword to true. Now you want to return a column which its first control is a row with alignment of space between, and its control are first senderTF and second senderPassTF. Let's scale the password field down, width of 200 and height of 50. Recall that this password is not the password of your Gmail account, and we need to generate an app password to be able to send email via a third-party app, that I show you how in a minute. Let's create a text field for recipients' mails with label recipients and height of 50. Then create another text field named subject.tf for subject of the mail and add them to the returning column below the first row that we added. And the main text field for body of the mail named self.maintf. Its multiline is true, so you can have multiple lines. Min lines and max lines equal to 11. With this setup, we can now have multiple lines and scroll through the text field. Finally, let's create two buttons. Send button, which is a text field that says send, and its onClick is set to self.sendClicked. SendClicked is a function that we'll create soon. Then clear btn, that is an icon button. Its icon is set to ft.icons.clear outline, and its onClicked is equal to self.clearClicked. Then create a row with alignment of start, which means they go to left side of the page, and its controls are the buttons that we created. Create sendClicked and clearClicked and pass them for now. The attribute is an event handler and passes some information to the functions that we don't need to use here, but they have to be there, otherwise you get an error. Save the script to apply the changes. I don't like the icon, let's change it to delete outlined. Nice, the UI is completed and it looks good to me. Let's now write the functionality of the app. First let's do the clearClicked function. I want to clear the maintf text field when it's clicked. You can clear all the fields if you want. So self.maintf.value is equal to an empty string. Then we need to update the app. You can call self.update which updates the whole app, but to save performance, we only update the affected widgets, so we only call self.maintf update here. Let's save and test it. It's time to write the main functionality of the app. Import SMTable app module and in sendClicked method, create a list named recipients. And assign it the value of self.recipientTF, split it by comma. That means if you have multiple recipients, you just put a comma between them in the recipient text field and they all get added to the list properly. It can be a dash or a space. I'm okay with the comma. Then we initialize smtable.smtp_ss. Its first attribute is the server that we use smtp.gmail.com, and the second attribute is the port number, which is recommended to be 587 for that specific server. Then we call s.startTLS, which encrypts the data. Then we log into the sender Gmail using s.login method. The first attribute is the self.senderTF.value, and the second one is the password, which is self.senderPassTF.value. Then we create the message, which is a if string. First we specify the subject by writing subject self.subjectTF.value. Then we put two new lines followed by self.maintf, which is the body. This formats the message and it knows what's the subject and what's the body of the mail. Finally, we call s.sendMail and set from address to self.senderTF. Two addresses is equal to recipients list that we created earlier and MSG to message. And s.quit, which closes the connection. Oh, from ADDR should be the value of self.senderTF. Well, now everything is ready except the app password for the sender Gmail. To generate an app password, log into your Google account in a browser of your choice. Click this 3 by 3 dots icon and choose Accounts. Go to Security section, scroll down and find two-step verification. Click on it, click Get Started, and here you have to enter your phone number and choose one of the methods of verification. Then Google tests your phone number and you turn the two-step verification on. When you turn it on, you can see this green checked icon that says On since a date, which means your activation has been successful. Then again click on it. Scroll the page all the way down, you should see App Password. Click on it. Here you can choose App and Device and finally click Generate. It gives a 16 letters password like this, and you have to use this password to send emails with the app we just created or any other third-party apps that you use. The application looks nice, modern and organized. More importantly, it works just fine. I've tested several times with the generated password and it hadn't any issues. If you face any error or problem, tell me in the comment section below. That's it guys, please like the video if you enjoyed it and subscribe to the channel for more cool stuff. In today's video, we'll be building a text-to-speech converter. There are many videos who use AI generated speech, which they pay for. We create one ourselves completely for free.
Without further ado, let's get started.
First, go to your terminal and install Tkinter and PyTTS X3 via pip. Then import Tkinter as TK and TTK from Tkinter. Finally, import PyTTS X3 as TTS. It stands for Python Text-to-Speech version 3. Then create a window named root by calling the TK class. Let's set the title as text-to-speech. Then we create a text widget with font Arial and size of 15. Text is the same as entry but for bigger scale. As you know, entry is just one line and is suited for getting short information like user and password in login pages. And let's grid it to the column and row 0. Next we'll create a frame for our buttons so they stay together. And grid it into the second row or row number 1. Now let's create our buttons. First, Say button. We set its parent as the button frame and its command to text-to-speech. For Save button, let's do the same, but we set its command to save. These are functions which we create later, and when we press the buttons, those functions get executed. Let's grid them, but we are gridding them on the frame, not the actual window. Finally, we call the main loop function of our root object. Let's create functions before testing. As you see, we have a big screen to type in, and when we reach the end of the line, we go to the new line, which is completely opposite of entry widget. The GUI is done. Let's write the functions. Before that, let's first initiate PyTTS X3 module as engine. Then first we get the user's input by calling the get method of text object and store it in t variable. First attribute is 0.0, which means the very first character, and second attribute is end, which means the last character of the user input. Basically, we get what is written thoroughly. And we pass the user input to say function of our engine to convert the text into speech. Finally, we call engine run and wait function to start the process. But before that, let's first choose the voice we want. PyTTS X3 has two voices by default, male and female. To choose between them, first create a variable named voices. We assign it engine.getProperty and give it voices as a string. Note that it is plural, voices. Now we have all the voices available. Let's call engine.setProperty. First argument is the name of the property that we want to set, which in this case is voice. And second argument is its value, voices brackets 0.id. 0 is the default value, which is the male voice. If you want, you can change it to the female voice by setting it to 1. I'm okay with the male voice. Next, we change the rate or speed of the narrator by setting the rate property. The default value is 200, but it's too fast for me. I prefer 150. Also, you can change the volume. Volume is between 0 and 1. Now let's save the voice into our hard drive. So once again, we get the user's input and pass it to the engine.saveToFile function as the first argument. Second argument is the name of the file. Finally, we call the run and wait method to complete the process. Let's see what we've created.
Well, guys, please like the video if you enjoy it and subscribe to the channel for more cool stuff.
Yeah, it's working properly. Let's test the save functionality. This is the folder which my script is in. When I press save, it should create our mp3 file. Let's see. Nice. That's it guys, it's working perfectly. If you have any questions or suggestions, leave a comment below. In today's video, we're gonna create a speech recognition program with a GUI. In the last video, we converted text to speech, now we do the opposite.
Without further ado, let's start coding.
First, let's install speech recognition, Tkinter, and Pygame. Let's import Tkinter as tk, ttk from Tkinter, and file dialog. File dialog is for creating a file explorer to choose our files. Then import speech recognition as SR and mixer from Pygame to play audio. Let's first create our GUI. Let's create a window named root by calling the tk class, and give it a title like speech to text. Next, let's create a text widget and give it the font Arial and size of 15, and then grid it to the window. In the first column and row, the advantage of text widget over label widget is that the user can modify the result easily. Now we need a button frame for our buttons so they stay together. First one is recognize button. Let's give it button frame as its parent. Then specify its text attribute as recognize. And finally pass recognize underline file to its command attribute. Let's do the same for our save button and pass save underline file function to its command attribute. Now let's grid our button frame to our main window in the second row below the text widget, and then grid the buttons to the button frame, because their parent is button frame, not the window. Finally, call the main loop function so the window listens to the changes and events. Before testing our GUI, we need to first create recognize file and save file functions that we pass to the buttons, and additionally, we create select file function to open up a file explorer and choose files that we want. Let's test it. It's okay. Let's first write the select file function. File path equals file dialog that asks open file name, and we specify the title attribute. File dialog is a Tkinter class that gives us a file explorer, and we can choose a file with ask open file name and store it. This function returns the files directory as a string for us, which we store it in file path variable. Then we simply return the file path. Now that we can choose our audio file, let's convert it to text. First, initiate recognizer as R. We initiate recognizer out of the function to minimize memory usage. In the recognize file function, we first create a variable named f for file and assign it select file function. Then with sr.audioFile, f as source, audio equals r.record source. First, we open the file explorer and choose the audio file that we want, then we store its path in f variables. Next, we pass f to sr.audioFile as source. AudioFile opens the file to see if it's an audio file. Finally, we read the source, which is our chosen file, by calling the r.record function and store it in audio. Audio variable is now ready to be converted to text. We first delete whatever that is in the text widget. 0.0 means the very first index and n means the last index. Then we call the r.recognize Google function to use Google's API to convert the speech to text. As you see, there are several options to use, which all of them except Sphinx are online and need internet connection to work. But the easiest way is to use Google's API. So pass the audio variable to the r.recognize Google function and store it in the text variable. Now we have the text and need to show the result to the user. For that, we call the insert method of our text widget. First attribute is the index that we want our text to be inserted, and second one is the string, which is text variable. As I said, this process needs internet connection, so we put it in a try except statement. First exception is unknown value error, which means the audio was too noisy and couldn't be recognized. And second one is request error, which occurs when we have internet problems. Now that we have the text, we can save it into our hard drive. We first select the directory and file that we want to save the text into. Then open it using open function as file. The first attribute is the file that we select, and second one is the mode. W mode means write and removes whatever that is in the file and replace it with the new values that we give it. If you want to just append, use A mode. Note that mode should be a string. Finally, we save the text in the text widget into our file using write function. Note that before saving, we have put the converted speech into our text widget. Let's recap. First, we create a file explorer in the select file function. We initialize the recognizer as R to get it ready to work. Then we select the audio that we want by calling select file function and store it in f variable. Next, we read the audio file and prepare it for conversion. Finally, we convert audio to text using Google's API and show it to the user. All of this happens when user clicks recognize button. Also, if user press save as button, you first select a file and save the text into it. One last thing. I want to first hear the audio to see if Google can properly recognize it. So first, let's initiate mixer from Pygame. Then we'll load the audio file, which is stored in F by calling mixer.music.loadF. And finally, we play it. So first we play the audio, then we convert it to text. Let's see what we've done. When I press recognize, we have the file explorer to select the audio. I've prepared the audio which is made by our text-to-speech converter program. If you want to know how, I'll put the video for you in the end screen. Let's test it now.
This is a test audio. Please like the video if you enjoyed it and subscribe to the channel for more cool stuff. Cheers.
And here we go. First the audio is played, and then we have it on the screen as a text. TextVisual lets us modify the text before saving. Let's see the saving functionality. As you see, it's perfect. That's it guys. You can watch this video to create cool generated AI by converting your text into speech. Please hit the like button if you enjoyed it and subscribe to the channel so you don't miss future videos. We'll create a QR code generator with GUI as you see that shows the QR code and saves it to the hard disk. For the graphical interface, we'll use Flat, which is based on Flutter for Python and makes the front end developing fast and easy. Also to generate QR codes, we'll use QR code module, which is very straightforward and simple. Let's get started. First install Flat and QR code via pip. Import Flat as FT, then import QR code. Let's create main function that has a page attribute as an instance of FT.page. Page is the root window and we can modify the height and width to 400 pixels. Apply the changes by calling page.update. Outside of the function, call ft.app and target is the main function that we just created. Now we have a basic page. Let's run the script, but instead of Python, we call Flat and path to your script in a terminal. By running the app with Flat instead of Python, we activate hot reload feature, which means if I change something of the UI, like the height, let's change it to 500, then save the script, app gets updated by itself and we don't need to close and rerun it every time. Let's create a text field for the inputs. Input TF equals ft.text field and its label is code, and the button to create the QR code. Create button equals to ft.icon button. Icon is ft.icons.draw. Icon size is 35 and onClick equals createClicked. CreateClicked is a function that gets executed whenever we click the button. It has a parameter that I name it E. It's an event handler and we don't use it here. Let's pass the function for now. Create main column, which is ft.column. Its alignment is center. Controls is a list that contains ft.row for now. Row has alignment of space between, which means put the blank space between the members, and its controls are input TF and create btn. Instead of updating the page, now we call ft.add and pass main column to it, which adds the main column to the page and updates the page. Save the script, and here we go. I want the user to enter the code, and by pressing the button, we show the QR code beneath them. For that, let's create QR code image, which equals to ft.image, and we set the src, which is source, to a non-empty string. This is just a dummy value to prevent the error as we specify the source of our image later. Add the QR code image to the column after the row. In the createClicked function, img equals to QRcode.make and we pass input tf.value. Then we call img.save and pass a string to it, which is the name of the file to be saved. I grab the value of input tf, which is user's input, and concatenate it with underlying QRcode.jpg. Save it and let's test if the saving function works. Go to your scripts directory and test it. Great, it works. Now we need to show the QR code in the app too. For that, we need to convert the image to base64 format. With open, the name of the file, let's copy and paste it, comma, rb as if. Here we reach the image file that we just saved and open it in binary mode to read. Base64 version equals base64.b64 in code, and we pass f.read. This converts the image to base64. Base64 module comes with Python and you don't need to install it. Let's import it. and print the base64 version. As you see, it's a long string, but before the string there is a bletter which we need to get rid of. QR code image.src_base64 equals base64 version, but we need to first decode it to UTF-8 to get rid of that B, which was before the string. Finally, we call QR code image.update to apply the changes. The image is illustrated properly, but it's not in the center of the page. Set the horizontal alignment of the main column to center. And there you go. QR code is shown perfectly, and if you change the code, the image will be changed perfectly. Also, they're all saved successfully. That's it guys, I hope you found the video useful. If so, please like and share the video to support me. Thanks, see you. Hi guys, welcome. Today we'll write in a script that gets a photo like this as input, detects the human faces, blurs them out, and saves the blur version beside the normal photo. For this we will use OpenCV module, which lets us do the face detection easily in less than 30 lines of code. Let's get started. Let's install OpenCV. In your terminal of choice, enter pip install opencv_python. While the module is getting downloaded and installed, go to your browser, enter this URL that is in the description box of the video. You should see hard cascade frontal face default.xml. Click the raw button, then right click the raw page and choose save as. That opens a file dialog for you to choose the destination of the download. I recommend downloading it to the directory that your script is. I already have it in the Python directory where my script is. Now that requirements are met, let's import CV2, which is the OpenCV module that we installed. Create face cascade variable and assign it cv2.cascade classifier. Then grab the name of the file that we downloaded earlier and pass it to the classifier as a string. As I said, if the file is in the same directory as your script, you can just pass the name, otherwise you should pass the path to XML file. Then you want to take the user input using input function and ask for the image that user wants to blur the faces in that image. And save it in user input variable. Now you read the image that user has provided by passing it to cv2.emerald and save it as image. In order to detect faces in the image, we need to first convert the colored image to gray, so gray equals cv2.cvdcolor, and we first pass the image, and second the method that we want to use, which is cv2.color_bgr to gray. Then faces equal to face cascade.detect multiscale. First parameter is gray, second one is the scaling factor, which I set to 1.1, and third min neighbors, which I set to 5. So detect multiscale grabs the gray image and detects faces in the image based on the factors that we set. You can play with the factors to see what's the best for you. Faces variable stores 4 parameters for each face rectangle that it finds: x, y, height, and width. For x, y, h, w in faces, face_ROI equals to image, brackets open, y colon, y plus h, x colon, x plus width. Image is a matrix, and here we are slicing it and grab the face rectangle that is detected and store it in face_ROI, which stands for region of interest. Then blur equals to cv2.medium blur. First we pass the face region of interest and then an odd number. The higher number, the higher blur. So far we have grabbed the detected faces and made a blur rectangle exactly the size of the faces. Now we should place the blur effect upon the faces. For that we copy the sliced image and assign it the blur effect. Out of the for loop, we call cv2.imshow to show the image. First parameter is the name of the window and second one is the picture that we want to show, which is image variable. Next we call cv2.imwrite to save the blurred image. First parameter is the name of the file that we want to save. I have JPEG image files, so I grab the name of the image and slice it and remove last 4 letters of the name, which is .jpeg extension, and concatenate it with _blur.jpg. This prevents overwriting your main images. If your image have different extensions, change the slicing to fit your situation. Second parameter is the image that you want to save, which is image variable. Finally, we have to call cv2.waitKey, which creates a loop for showing the image and lets us close the image with pressing a key. Here I got 3 JPEG image files named test, test2, and test3. Let's see if the script works. First, I want to blur test3.jpg. It works, but the image is too large and we need to downscale it. Resize the image equals to cv2.resize. First is the image, second one is the desired size, a tuple of 0 and 0, Third and fourth parameters are fx and fy, which are both 0.05, and we show the resized image. Let's see the result. All the faces are perfectly detected and blurred, but there are some other areas that have been detected as faces wrongly. Second image too, but if you look sharply, program has detected the feet as a face. And last image, as you see, is not good at all, but by playing around with the parameters, you can make it better and better. And all the images are successfully saved. That's it guys, we made a face detector in less than 30 lines of code. Please like the video if you enjoyed it, and subscribe to the channel for more cool stuff. In today's video, I'm gonna create a modern graphical user interface in a new way. Flutter is a UI toolkit to create GUI fast, easy, fun, and modern. You can code a program once and build it for iOS, Android, Windows, Mac, Linux, and also web natively. And they are incredibly fast, but unfortunately for us, Flutter uses Dart programming language, which both are made by Google. So if you want to use Flutter, you need to learn a new language. But recently, Flit has come into the game, which is based on Flutter, with some changes using Python. The developers of Flit want to make it available for different programming languages, but at the time of recording this video, Flit is just available for Python. Let's install Flit and start coding. Import Flit as FT. Let's create a function named main and create a parameter named page. Also, we declare its type. Page::ft.page means that the page should be an instance of ft.page, and ft.page is a window, our root window, and we pass the function, which means do nothing. Then we call ft.app and give main to its target attribute. Simply we say that our app is main function. Let's see the result. Okay, this is the default window of Flit. We can set its height and width by calling page.window height and width to 400. And don't forget that page is our root window. But when I run it, nothing happens. Well, Flit is not like tkenter. And when we make a change, we need to call update method of our window. So let's do it. Page.update. And now changes are applied to our window. We can set the title of our window by calling title property. I don't like example, so let's change it to counter. I forgot to capitalize it. We have run the program 5 times just for scaling and naming it. That's just frustrating. We need to close the program and run it for every single change. Flit has addressed this issue by hot reload. Let me show you what hot reload is. Always we run our Python program with Python, but this time we run it with Flit. Go ahead and write Flit space path to your script and hit enter in your terminal of choice. Now you have the program. Let's change something. Let's change height to 600 and press save. And here you go. As soon as you change your code, the program gets updated and we don't need to run and close the program a million times. There are 2 more great features that I'll show you at the right moment. For now, let's change the theme of our window by setting page.theme mode to ft.thememode.dark. I guess the light mode is better, as my desktop and editor are both dark. Let's create a text field and give it the value of 0 and store it in number variable. Text field is the same as entry in tkenter. When I press save, nothing happens. And that's because we haven't added our text field into our page. Let's add it. Add function adds widgets, which are called controls in Flit, to the page and updates the page. So if I remove page.update, nothing will break. As you see, the text field is added to the page at the very top of the page. We can change the position by setting page.vertical alignment to main axis alignment. End means very bottom of the page, and start means very top of the page, which is the default option. As you see, when we add widgets or controls, they get added vertically. If you want to have them horizontally, you can use ft.row class. Controls property is a list of controls or widgets to add. Let's first decrease the width of text field and add more text fields to our row. As you see, we have them horizontally beside each other. We can change their position by setting rows alignment property to main axis alignment, just like our page. Almost every container widget has an alignment property to easily place and order the widgets precisely. You can even change the text position in the text field by setting its text align property to ft.textAlign. Now let's add 2 icon buttons and set their icon property to ft.icons.remove and add. You can access tons of modern icons in Flit. Also set their color by changing icon color property. You can also access a lot of pre-made colors with different tones by calling ft.colors. And this is why Float is so powerful. Everything that you need is provided for you. Now let's create add function and we give it a parameter named e. E parameter should be there, but we don't need to use it necessarily. Now we want to increase the value of number. Number.value equals integer of number.value plus 1. And we need to convert it to string again by calling str method, because text field just accepts strings. Now let's do the same, but this time we subtract number value by 1 and change the name of the function to subtract. I want to add the text field value by clicking plus icon and subtract it by clicking minus icon. So let's set their onClick attribute to the functions that we created. OnClick attribute is the same for command attribute of tkinter. When we press icon buttons, the value of onClick attribute gets executed. But when I press the buttons, nothing happens. Can you tell why? Because we didn't call page.update after we changed the value in our functions. As I earlier said, after any change in Float, we need to call page.update to apply the changes. Let's save and test it. It's working as expected. Now it's time to show you another Float's great feature. As I said, you can create an app and build it for different platforms with only writing the code once. If you want to see the app in your web browser, you can set view attribute of app function to ft.webbrowser. For this, you need to run the program with Python. Here you go. You have your program as a web application. There is one more thing. If you make a mistake in your code, the program doesn't crash. As you see, it gives us an error in our window, and if we mitigate it, the error is gone. That's it, guys. If you want to see more of Float, please leave a comment below. Also like the video if you enjoyed it, and subscribe to the channel for more cool stuff. Take care, see you later.